Hello there, and welcome to the Sleepy Science Channel. Tonight, we're stepping into an ancient and hidden world, where leaves, roots, and bark carry chemistry powerful enough to shape human lives. For thousands of years, people have turned to plants, not just for food or shelter, but for healing. Long before laboratories and modern medicine, there were forests, fields, and careful observation. A bitter leaf, a fragrant flower, or a simple piece of bark, each one holding something unseen, yet powerful enough to change how the body feels and functions. What's most fascinating is that these remedies were never made for us. They evolved as tools for survival, defenses against insects, signals to the environment, and ways for plants to endure harsh conditions. And yet, in those same compounds, we discovered relief, recovery, and even the ability to save lives. As we explore this fascinating world, you may start to get a glimpse at how remarkable plants really are. They are like living chemistry labs, quietly shaping molecules with extreme precision. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is settle in. Let your body soften and allow your mind to unwind. And as the day begins to gently fade away, join me as we discover this ancient wisdom together. Let's begin. Some of humanity's most powerful medicines were first found in plants. That idea can feel almost impossible when you picture a hospital full of machines, glass, and stainless steel. Yet many of the compounds that changed medicine began in forests, meadows, and mountain slopes. Plants could not run, bite, or hide, so they evolved chemistry instead. They built molecules to defend leaves, stop microbes, survive heat, and warn off hungry mouths. Humans stepped into that chemical world and slowly learned that some of those same compounds could lower pain, steady a heartbeat, stop infections, or attack cancer cells. In other words, medicine did not appear from nowhere. It was gathered from living things that had been solving biological problems for millions of years. Once you notice that, a field of weeds stops looking ordinary. It starts to feel like a library written in scent, bitterness, color, and sap, where survival itself has been turning into pharmacology since long before anyone used the word. A willow tree helped inspire the painkiller we now call aspirin. Long before anyone could explain inflammation or isolate active chemicals, people noticed that willow bark could reduce pain and fever. That mattered because fever and aching joints were once far more dangerous than we tend to imagine. They could weaken a person for days or weeks, and there were few reliable options. Willow's bark contains salicin, a compound that the body can turn into a salicylate. Over time, chemists studied that old remedy and worked towards something more stable and gentler on the stomach. The result was aspirin, one of the most familiar medicines on Earth. What makes the story so striking is its scale. The medicine taken for headaches, fevers, and heart health by millions of people traces part of its history back to a tree growing beside water. One rough, bitter bark helped open the path from traditional plant remedies to modern drug design, and that is an astonishing leap. The rosy periwinkle gave doctors drugs that transformed childhood leukemia treatment. At first glance, it does not look like the kind of plant that would change the fate of children in hospitals. It is small, decorative, and easy to miss among garden flowers. Yet inside that modest plant, scientists found compounds that could interfere with cell division. That discovery became profound when doctors realized those molecules could be used against cancers in which cells divide wildly and without control. From the rosy periwinkle came vincristine and vinblastine, drugs that became important tools in cancer treatment. Childhood leukemia, once far more likely to be fatal, became much more survivable because of advances like these. The emotional force of that story is hard to overstate. A flower that might sit quietly in a warm garden ended up helping children reach birthdays, school days, and futures they might otherwise have lost. It is one of the clearest examples of how plant chemistry can cross into medicine and alter human destiny. Foxglove can steady a failing heart, even though the plant is poisonous. Few stories capture the double nature of plant remedies more vividly than this one. Foxglove is beautiful. It rises in tall spires with hanging purple bells, and it looks almost made for admiration. But inside it are cardiac glycosides, potent compounds that can strongly affect the heart. In careful medical use, substances derived from foxglove help doctors treat certain heart conditions by strengthening contractions and improving control over rhythm. In the wrong dose, though, the same chemistry can become dangerous or fatal. That tension is exactly what makes plant medicine so compelling. The difference between remedy and poison is not always the plant itself. Very often, it is dose, preparation, and knowledge. Foxglove reminds us that nature is not arranged for human comfort. It produces molecules for its own purposes. We enter that world at our own risk, and sometimes our great medical breakthroughs come from learning how to handle something that was never safe to approach casually. Cinchona bark changed history by helping people survive deadly malaria. There was a time when whole regions could become traps for anyone without protection from this disease. Malaria shaped trade, war, settlement, and empire because it could kill with terrifying efficiency. Then, Cinchona entered the story. The bark of this South American tree contains quinine, a compound that became one of the great anti-malarial medicines in human history. Its importance went far beyond the sickbed. By helping people survive in places where malaria was rampant, it altered exploration, colonial expansion, and military campaigns. That does not make the history simple or noble, but it does make it enormous. A tree in Andean forests ended up influencing events on several continents. Even the taste of tonic water is a faint echo of that story, since quinine was once mixed into drinks because of its bitterness. Very few remedies can claim to have shaped both biology and geopolitics. This one did, and the world changed around it. Artemisia annua led scientists to one of the world's best anti-malarial drugs. This plant, sometimes called sweet wormwood, carries one of the most important medical stories of the modern age. Malaria remained a global killer even after older treatments began to lose strength against resistant parasites. Scientists searching for new answers turned to traditional knowledge and historical records. From Artemisia annua came artemisinin, a compound with remarkable power against malaria. It acts fast, and in modern combination therapies, it has saved enormous numbers of lives. What makes the discovery especially striking is the path it took. It was not simply a matter of picking a plant and hoping for the best. It required careful reading, extraction methods, chemistry, testing, and persistence. The result was so important that it reshaped treatment across much of the world. In the story of plant remedies, this is a brilliant reminder that ancient practice and modern science do not always stand apart. Sometimes they meet, and when they do, the effect can be global. Yew trees produce compounds now used to fight several major cancers. Yews have an ancient, almost solemn presence. They grow slowly, live for astonishing lengths of time, and often seem more like symbols than sources of medicine. Yet inside their tissues, scientists found taxanes, a group of compounds that interfere with how cancer cells divide. One of the most famous, paclitaxel, became a major cancer drug used in the treatment of several forms of the disease. There is something remarkable in that contrast. A tree associated with stillness and endurance turned out to contain chemistry capable of disrupting one of the most dangerous processes in the body. The story also shows how difficult plant medicine can be in practice. Extracting enough of the active compound was once a serious challenge, which pushed researchers toward new production methods and related compounds from other sources. So, this is not only a story about a tree. It is also about ingenuity, scarcity, and the way a single botanical clue can open an entirely new medical strategy. Plants make chemical weapons for survival, and some became human medicine. A plant cannot leap away from a beetle, outrun a fungus, or bite back at a grazing animal. So it fights with molecules. Some are bitter enough to discourage feeding. Some damage microbes. Some interfere with nerves, digestion, or growth. In the plant's world, these are weapons, alarms, shields, and traps. In our world, some of those same molecules became the starting point for therapies. That is one of the strangest and most beautiful reversals in medicine. A compound evolved to punish an insect might, in another context and dose, relieve human pain or kill a parasite. Chemistry does not care about intention. It only interacts with living systems. Once you see that clearly, the entire green world becomes more dramatic. Leaves are not passive decorations. They are chemical battlegrounds. Every scent released after rain, every bitter herb, every sticky resin may be part of a survival strategy. Medicine often begins when humans learn how to borrow from that invisible war. Entire medical traditions began by noticing which leaves, roots, and barks healed. Before microscopes, clinical trials, or modern chemistry, there was pattern recognition. Someone drank an infusion and recovered. Someone else used a crushed leaf on a wound and saw swelling ease. Over generations, those observations were remembered, compared, refined, and passed along. That is how many healing traditions grew, not from fantasy, but from repeated attention to what seemed to help. Of course, not every old remedy worked, and some were dangerous. But many systems of traditional medicine preserved real insight because people kept testing plants against lived experience. The root might become known for digestion, a bark for fever, a seed for worms, a resin for skin. What fascinates me most is the patience of that process. Knowledge was often carried in memory, ritual, apprenticeship, and language long before it entered books or laboratories. In that sense, every remedy was also a story about observation. Human beings watched the living world closely, and sometimes the world answered. A quiet herb garden can contain molecules powerful enough to change history. Walk through one slowly, and it may seem harmless, even domestic. You smell mint, brush past lavender, notice rosemary, thyme, sage, chamomile. Nothing about the scene suggests war, epidemics, surgery, or pharmacology. Yet many of these familiar plants carry strong chemistry. Some soothe digestion. Some affect microbes. Some influence inflammation, mood, pain, or breathing. Across centuries, humble kitchen and monastery gardens were not just places of beauty or flavor. They were storehouses of trial, memory, and practical healing. A person with no access to modern medicine might once have depended on those beds of leaves and flowers for relief from coughs, cramps, wounds, or restless nights. That is what makes such a garden feel extraordinary to me. It shrinks the distance between the ordinary and the historic. The same patch of soil that gives off scent in summer may also connect to plague years, voyages, childbirth, field medicine, and the long human search for remedies growing within arm's reach. Ancient healers often discovered remedies by watching animals eat certain plants. Long before formal botany or chemistry, people lived close enough to the natural world to notice patterns that survival itself would have sharpened. If a deer with stomach trouble kept returning to one patch of leaves, or a sick dog chewed grass and then seemed relieved, that behavior was hard to ignore. Across many cultures, stories emerged of people learning from animals, not in a magical sense, but through careful watching. Monkeys, elephants, bears, and birds all became part of an informal library of clues. Of course, imitation could be risky, because what helps one species may poison another. Still, the idea is fascinating, because it places medicine in a shared world of trial and response. Humans were not standing apart from nature, inventing remedies from nothing. They were observing other creatures already engaged in their own survival. In that sense, some of the earliest healing knowledge may have begun as a form of deep attention. Many plant remedies began as bitter defenses against hungry insects. Bitterness is one of the oldest warning signs in nature. To an insect, a bitter leaf may signal trouble ahead, because the taste often comes from compounds designed to disrupt feeding, growth, or digestion. Plants evolved these chemicals because they needed protection, and they had no claws or speed to rely on. That is what makes the human story so surprising. We learned that some of those same bitter compounds could affect our bodies in useful ways. The unpleasant taste that tells a caterpillar to back away might, in another context, stimulate digestion, alter circulation, or act on infection. Herbal traditions all over the world noticed that the harshest plants were often the most potent. A sweet leaf might nourish, but a bitter one might act. That turned the human mouth into a kind of testing instrument, crude but meaningful. Sometimes the first clue that a plant mattered was simply that the body recoiled before the mind understood why. The same plant can heal at one dose and harm at another. That truth sits at the heart of nearly all medicine, and plant remedies make it especially vivid. A cup of tea made from a medicinal herb might soothe the stomach or calm a spasm. A stronger extract from the same plant could overwhelm the body and cause real harm. The chemistry has not changed. What changes is the amount, the preparation, and the condition of the person taking it. This is why old healers paid such close attention to pinches, spoonfuls, steeping times, seasons, and body size. They were navigating a narrow bridge between benefit and danger. Modern pharmacology did not invent that problem. It inherited it. What fascinates me is how this changes the way we see nature. A plant is not simply good or bad. It is potent. That is a more serious and more interesting word. Potency means relationship. The body meets a substance, and the outcome depends on how much arrives and when. Bark, root, seed, flower, and resin can all hold different medicines. A single plant is not one uniform substance. It is more like a small chemical city, with different districts making different things for different purposes. The bark may defend against fungi and burrowing insects. The root may store compounds that shape microbial life in the soil. Seeds often need strong protection, because they carry the future of the species. Flowers may produce scent molecules that attract pollinators or deter certain pests. Resin can act like a sticky shield, sealing wounds and blocking invasion. When humans began using plants medicinally, they discovered that choosing the wrong part could mean getting no effect at all, or a completely different one than expected. That is why traditional herbal systems became so precise. They did not simply say, use the plant. They said, use the bark, the young leaves, the dried root, the gum, the unopened bud. A remedy could depend less on the species than on the exact piece gathered. Some plant remedies work because they calm inflammation deep inside tissues. Inflammation is one of the body's oldest defenses and one of its greatest risks. It can protect us from infection and injury, but when it runs too long or too hard, it begins to damage the very tissues it was meant to save. Joints become swollen, skin reddens, airways tighten, and pain lingers because the alarm never fully switches off. Many plant remedies matter because they seem able to soften that alarm. They do not necessarily erase the cause, but they can influence the signaling pathways that keep inflammation burning. That is why so many traditional remedies were used for aching limbs, irritated skin, sore throats, or digestive discomfort. People may not have known the language of immune cells and inflammatory mediators, but they knew the feeling of heat, swelling, and relief. The wonder here is that plants evolved molecules that can nudge that ancient bodily fire. A leaf or root can alter the chemistry of distress. Others fight microbes with compounds evolved long before humans existed. Bacteria and fungi were battling each other ages before animals arrived, and plants were caught in that conflict from the start. Every root in the soil and every leaf in damp air faced invasion, rot, and decay. Over immense stretches of time, plants evolved compounds that could slow microbial growth, damage cell walls, disrupt enzymes, or make tissues harder to colonize. By the time humans entered the picture, that chemical warfare had already been running for hundreds of millions of years. What we call a remedy was often part of an ancient ecological arms race. When people crushed a leaf onto a wound or brewed an aromatic herb for illness, they were tapping into molecules shaped by struggles far older than our species. That is part of what makes plant medicine feel so deep. It is not only human culture. It is evolutionary history made useful. Long before doctors existed, the green world had already been experimenting with antimicrobial chemistry. Peppermint can relax gut muscles and ease certain kinds of stomach pain. Peppermint feels bright and cool in the mouth, but its more interesting effects often happen farther down. The oil contains menthol and related compounds that can influence smooth muscle, especially in the digestive tract. When those muscles tighten in the wrong pattern, the result can be cramping, discomfort, bloating, or a sense that the abdomen is in knots. Peppermint has become well known because it can help those muscles loosen, which changes the experience from gripping pain to release. That is a remarkable shift for something many people first meet as a flavor in sweets or toothpaste. In medicine, the most fascinating substances are often the ones that move between ordinary life and serious usefulness. Peppermint does exactly that. A smell associated with freshness also belongs to a plant whose chemistry can alter bodily tension. It reminds us that the digestive system is not just a tube. It is a rhythm, and some plants can change the beat. Ginger helps settle nausea by acting on the digestive tract. Nausea is such a strange and powerful sensation because it can take over the whole body at once. The stomach feels unstable, the mouth changes, motion becomes unpleasant, and even thought narrows into a single wish for relief. Ginger became famous because it can sometimes interrupt that cascade. Its active compounds seem to influence digestive activity and signaling in ways that reduce queasiness, especially in motion sickness, pregnancy-related nausea, and some forms of post-treatment upset. What makes this fascinating is how often people have rediscovered it independently. Across continents and centuries, ginger kept returning as a trusted answer whenever the body felt unsettled by movement, illness, or excess. It is warming, sharp, and unmistakable, which may be one reason it stayed memorable in traditional practice. But the deeper reason is likely simple. It worked often enough to earn loyalty. A knotted stomach is one of the hardest things to ignore, and ginger became one of the hardest remedies to forget. Aloe vera gel can cool irritated skin after heat or friction. There is something almost architectural about this plant. Thick leaves hold clear gel inside, as though the remedy were being stored in quiet reserve beneath a protective wall. When that gel is applied to skin irritated by sun, rubbing, or minor heat exposure, many people feel immediate relief. Part of the appeal is physical. It is moist, cool, and soothing the moment it touches the surface. But aloe also contains compounds and polysaccharides that have made it a lasting subject of medical interest, especially for skin comfort and support during recovery. What gives it such staying power in human culture is how visible the effect can be. You do not need abstract theory to notice that angry skin feels calmer. That directness matters. A plant sitting on a windowsill can suddenly become the first place a person turns after too much sun or a raw patch from friction. Few remedies feel so simple and so strangely prepared in advance. Clove oil numbs pain so effectively, dentists once relied on it. Few plant remedies have such an immediate reputation. Clove is warm, sweet, and familiar in baking, yet its oil contains eugenol, a compound with striking numbing and antiseptic properties. Before modern dental anesthetics became standard, clove oil was often used to quiet tooth pain and make treatment more bearable. That connection between kitchen spice and dental relief feels almost unbelievable until you imagine the scene. A person suffering from a raging toothache, one of the most consuming pains the body can produce, finds real comfort from a plant bud dried and stored in a jar. That is not folklore surviving on charm. That is chemistry reaching straight into the nerves. Even now, the scent of clove can carry a faint echo of the dental world because it truly belonged there. It reminds us that pain relief did not always arrive in sealed syringes or tablets. Sometimes it came from a spice trade route and a flower that never opened. Eucalyptus releases aromatic oils that can make breathing feel easier. Part of the power of this plant lies in the way it announces itself before you even touch it. The scent rises sharply into the air, clear and penetrating, and almost seems to move through the head as much as through the nose. Eucalyptus leaves contain volatile oils, especially cineol, that became closely associated with respiratory relief. When used in steams, rubs, and inhaled preparations, those oils can create a sensation of opening and freshness that people often find deeply comforting during colds or congestion. That matters because breathing difficulty is not only physical. It can feel frightening and claustrophobic, as though the whole world has narrowed. A plant that changes that experience, even partly, earns a powerful place in memory. Eucalyptus shows how smell itself can become part of medicine. The remedy arrives not as a pill or poultice, but as vapor, moving through air and entering the body in the same element that the body is struggling to draw in. Senna leaves contain natural laxatives that stimulate the bowels. For most of history, constipation was not a minor inconvenience. It could become painful, persistent, and dangerous, especially when diet, illness, travel, or age slowed the body's normal rhythm. Senna mattered because it acted. The leaves and pods contain compounds called senocides, which can stimulate the intestines and encourage movement when the system has stalled. That directness gave the plant a serious place in medicine. Many remedies soothe, coat, or support. This one pushes. It tells the bowel to wake up and contract. There is something almost mechanical about that, yet the chemistry is entirely botanical. The fascination lies in how a leaf can influence one of the body's most private and stubborn functions. Traditional healers understood that too much could be harsh, which is part of the story as well. A remedy for blockage must not become a source of strain. Senna is memorable because it shows plant medicine at its most practical, forceful, and unmistakably effective. Psyllium husks can absorb water and soften digestion from the inside. This remedy works by a principle so physical that you can almost picture it happening. The outer husk of psyllium seeds is rich in soluble fiber, and when it meets water, it swells into a gel-like mass. Inside the digestive tract, that soft bulk changes texture, moisture, and movement all at once. Stools can become easier to pass, the bowel can move more regularly, and the entire process of digestion can feel less dry and resistant. What makes it fascinating is that the effect is not dramatic in the way a stimulant is dramatic. It is structural. It changes the environment from within. That gives psyllium a quiet elegance. Rather than forcing the body, it helps reshape the conditions the body is working in. A tiny husk from a plant seed becomes a tool of internal engineering. The digestive system responds not because it has been shocked, but because the material passing through it has been transformed. Licorice root has been used to soothe sore throats and coughs. There is a reason this root appears again and again in old formulas for irritated airways. It has a natural sweetness, but the more interesting feature is its soothing quality. Licorice contains compounds that can coat and calm inflamed mucous membranes, which helps explain its long use for scratchy throats, coughing, and that raw feeling left behind by illness or overuse of the voice. In the world of plant remedies, not everything works by attacking or stimulating. Some substances matter because they soften contact. They reduce irritation by creating a gentler interface between tissue and air. That can feel almost miraculous when each swallow or cough seems to scrape. Licorice also carries an old reputation of comfort, which is part chemistry and part experience. A harsh throat makes the whole body tense. A remedy that eases that harshness can feel larger than its mechanism. It turns breathing and speaking back into ordinary acts, and that return to ordinary is powerful. Chamomile became famous for its gentle role in calming the body. Few herbs have traveled so widely into daily life. Chamomile appears in cups before bed, in comfort rituals, in family kitchens, and in memories of being looked after. Its reputation grew because it seemed to bring ease without force. People turned to it for restlessness, mild digestive upset, tension, and the need to settle after a day that had run too hard. Part of its power may lie in compounds that interact with the nervous system in subtle ways, but the bigger story is its consistency. Again and again, across generations, people reached for this flower when the body needed softening rather than shock. That matters. Not every remedy needs to conquer. Some need to persuade. Chamomile belongs to that second kind. It makes the body feel less defended. In a world of dramatic medicines, that can sound modest, yet it is exactly why the plant endured. Relief is not always about intensity. Sometimes it is about permission to unclench. Turmeric contains curcumin, a bright pigment studied for anti-inflammatory effects. This plant announces itself through color before anything else. The deep golden stain clings to fingers, bowls, fabric, and memory. It feels more like sunlight made solid than like medicine. Yet the pigment that gives turmeric its color, curcumin, became the focus of intense scientific interest because of its possible role in modulating inflammation and related processes in the body. That journey from kitchen spice to laboratory subject is one of the most intriguing paths in plant medicine. It shows how an ordinary ingredient, used for centuries in food and traditional healing, can later become the center of biochemical research. The challenge has never been only whether it has effects, but how those effects behave inside a real human body, where absorption and metabolism matter. That complexity makes the story better, not weaker. Turmeric is not interesting because it is simple. It is interesting because it sits at the exact point where tradition, chemistry, and modern evidence keep meeting. Garlic produces sulfur compounds that help explain its medicinal reputation. Crush a clove, and the smell arrives instantly, sharp enough to fill a room and impossible to mistake. That smell is not an accident. It comes from sulfur compounds released when the plant's tissues are damaged, as though the remedy wakes up only when the bulb is broken open. Chief among these is allicin, a reactive substance that helps explain why garlic built such a strong medicinal reputation across cultures. People turned to it for infection, circulation, and general hardiness, long before they could describe its chemistry. What makes garlic fascinating is that it feels both ancient and alive. You can sense its activity with your own nose. The plant does not seem passive. It seems to answer being cut with a chemical event. Few remedies make their presence so dramatically known. A clove on the chopping board becomes a reminder that cooking, healing, and defense were never entirely separate. Sometimes the kitchen was also the first laboratory. Tea tree leaves yield an oil with strong antimicrobial properties. This plant's medicinal story is closely tied to place. For generations, Indigenous Australians used the leaves in practical ways. And later, the distilled oil became widely known for its action against microbes. Tea tree oil is intensely aromatic, and its reputation grew because it could be applied to minor skin problems where people wanted cleanliness, dryness, and a sense that something active was happening. That last part matters more than it sounds. Many remedies work invisibly, but tea tree feels purposeful the moment it touches the skin. The scent alone tells you that complex chemistry has arrived. Modern interest focused on compounds such as terpinene 4-ol, which help explain the oil's antimicrobial effects. Yet the more compelling part of the story is how a leaf from one landscape became a global household remedy. It shows how local plant knowledge can travel far while still carrying traces of the environment and people who first understood its usefulness. Thyme makes thymol, a plant chemical used in some mouthwashes. Tiny thyme leaves do not look like the source of anything powerful. They seem almost delicate, the sort of herb that belongs beside roast vegetables rather than in medical discussions. Yet thyme produces thymol, a compound with notable antimicrobial activity that found its way into oral care products, including some mouthwashes. That leap from garden sprig to bathroom cabinet is one of those stories that makes plant remedies feel almost hidden in plain sight. For a long time, aromatic herbs were valued because they seemed cleansing, preserving, or purifying. Later, chemistry began to explain why. In the case of thyme, scent and function are closely connected. The same pungent character that defines the herb in cooking also signals molecules that can affect microbial life. It is a reminder that a mouthwash bottle may hold a diluted echo of old herbal knowledge. The modern product feels clinical, but part of its ancestry still belongs to a sunlit herb bed. Sage was prized for sore throats long before modern laboratories existed. This herb acquired a remarkable reputation in traditional medicine, and not by accident. Sage leaves are rich in aromatic compounds and tannins, which help explain why they were so often prepared as gargles, infusions, and rinses for irritated mouths and throats. A sore throat can make speech feel costly and swallowing feel sharp, so any remedy that offered noticeable relief would have been remembered quickly. Sage earned that memory. It also carried an aura of seriousness in many cultures, almost as though people sensed that the plant did more than flavor food. Its name became tied to wisdom, health, and preservation, which tells you how strongly it impressed those who lived with it. What fascinates me most is how a rough, grey-green leaf could build such authority across centuries. Before anyone spoke of phytochemistry, people were already trusting it with one of the body's most exposed and vulnerable passages, the place where voice and breath begin. Rosemary carries aromatic compounds that may affect memory and mood. This herb has long been linked with remembrance, and that old association turns out to be more than poetic. Rosemary releases volatile compounds that travel quickly through the air, which means its chemistry can reach the brain through smell with unusual immediacy. Researchers have explored whether some of those compounds may influence alertness, attention, and certain aspects of memory. That does not make rosemary a miracle cure, but it does make it far more interesting than a kitchen seasoning. Imagine brushing past a shrub and breathing in molecules that might subtly change mental state. For earlier generations, that experience was direct and memorable. A plant used in cooking, ritual, and medicine also became connected with clarity of thought and emotional steadiness. What fascinates me is the speed of it. You do not even need to swallow anything. The remedy begins in the air, which makes rosemary feel less like an herb and more like atmosphere with consequences. Lemon balm has long been used to quiet restlessness and tension. There is something disarming about this plant from the first moment you crush a leaf. The scent is soft, bright, and unexpectedly comforting, which may be one reason it built such a strong reputation for easing unease. Across herbal traditions, lemon balm was turned to when the body felt overstimulated and the mind would not fully settle. People used it for nervousness, low mood, poor sleep, and that peculiar state where the whole system seems wound too tightly. What makes it so compelling is that it belongs to the mint family, yet it feels gentler in character than many of its relatives. Its chemistry has drawn attention for possible effects on calm, cognition, and mild stress responses. That combination gives the plant an unusual role. It is not about heavy sedation or dramatic force. It is about changing the emotional texture of a moment. Some remedies conquer symptoms. This one seems to soften the room around them. Lavender became a remedy not through magic, but through chemistry. Its purple flowers and famous scent make it easy to see why people once wrapped lavender in mystery. Yet the deeper story is even more interesting. The plant earned its medicinal place because its essential oil contains compounds that can influence how the body experiences tension and agitation. When people speak of lavender as calming, they are describing a real interaction between plant molecules and human physiology, not a charming illusion. That matters because lavender often gets dismissed as decorative, as though it belongs only in soap, sachets, or gardens. In truth, it sits at the intersection of fragrance and pharmacology. The scent can alter atmosphere, memory, and expectation, while the chemistry itself has been studied for effects on anxiety and rest. What I love about that is how it redeems beauty without reducing it. A lovely flower does not need to be magical to be astonishing. It is enough that its perfume can change what the body feels. Fennel seeds were chewed for digestion in many ancient cultures. That small act tells a surprisingly large story. After heavy meals, during travel, or when the stomach felt swollen and resistant, people reached for fennel because it was portable, memorable, and effective enough to survive across generations. The seeds carry a sweet, slightly licorice-like taste, but underneath that pleasant flavor lies a real medicinal reputation tied to digestion and comfort after eating. Ancient households, market stalls, and caravans all had reason to value something that could be carried in a pouch and used without preparation. That practicality is part of what made fennel endure. It was not distant or ceremonial. It was close at hand, woven into daily life. There is something fascinating about that intimacy. A remedy does not always enter history through grand discoveries. Sometimes it stays alive because people keep chewing it after supper and passing the habit on. When enough generations do that, a seed becomes more than food. It becomes inherited evidence. Anise and fennel soothe digestion by slightly relaxing the gut. These two plants are often grouped together because they share a sweet aroma and a long reputation for easing digestive discomfort. Yet the really interesting part is what that relief may involve. Digestive distress is not always about injury or infection. Often it is about tension, spasm, trapped gas, and muscles contracting in ways that feel tight, uneasy, or painful. Anise and fennel seem able to help because their compounds can slightly relax smooth muscle in the gut. That sounds modest, but the effect can feel dramatic when the abdomen has become hard, restless, and uncomfortable. It is a beautiful example of how a small shift in physiology can change a person's whole experience. You do not need a violent intervention when the problem is a rhythm gone wrong. You need something that eases the grip. These seeds have earned their place because they can help the digestive system stop bracing and start moving more naturally again. Marshmallow root contains soothing mucilage that can coat irritated tissues. The magic of this plant lies in texture. When marshmallow root is prepared with water, it releases mucilage, a slippery, gel-like substance that seems almost designed to comfort raw surfaces. For throats made scratchy by coughing, for digestive passages irritated by friction or inflammation, that coating action can feel deeply relieving. It does not fight with the body. It shields it. That distinction matters. In medicine, some remedies act by attack and others by protection. Marshmallow belongs firmly to the second kind. It creates a softer meeting point between tissue and the world moving across it, whether that world is air, food, or stomach contents. The old use of this root makes perfect sense once you imagine how unbearable a dry, inflamed throat can become. A plant that turns water into a soothing layer would have felt almost ingenious. What fascinates me is that the chemistry becomes a physical presence, a cushion made by a root. Slippery elm gained fame for the same soft, protective reason. There are few remedies whose value can be understood so quickly by touch alone. When the inner bark of slippery elm is mixed with water, it thickens into a smooth, soothing substance that seems made for irritation. It became widely used because that texture could comfort inflamed throats, calm unsettled digestion, and create a protective layer where tissues felt exposed or scraped. That may sound simple, but simple is sometimes exactly what suffering needs. Not every problem requires a strong chemical shove. Sometimes the body is asking for less friction, less contact, less insult. Slippery elm answered that need in a form people could feel immediately. The bark did not promise drama. It offered ease. That is why it lasted. In the long history of plant remedies, substances that visibly change how a body's surface feels tend to be remembered. A tree that could turn into comfort with a little water was always going to earn a serious place. Plant mucilage can feel simple, yet it changes how tissues respond. At first glance, mucilage seems unimpressive. It is slippery, thick, and a little plain, nothing like the dramatic bitterness of potent alkaloids or the sharp scent of essential oils. Yet that humble texture can be medicinal in a very direct way. When mucilage-rich preparations meet irritated surfaces, they form a moist, protective interface that reduces friction and alters sensation. A throat may hurt less when swallowing. A stomach or bowel may feel less scraped and reactive. A dry cough may become less harsh because tissues are no longer meeting air in such an exposed state. What fascinates me is how physical the effect is. This is not only chemistry in the abstract, it is architecture. The plant changes the surface conditions the body has to endure. That can shift inflammation, comfort, and response without force. In a world that often admires the strongest remedies, Mucilage reminds us that relief sometimes begins with softness rather than power. Calendula flowers became popular because damaged skin often tolerates them well. Bright orange petals do not look like medicine, yet calendula built its reputation through repeated contact with one of the body's most vulnerable frontiers, the skin. When skin is irritated, healing is not only about what acts strongly, it is also about what the tissue will accept without protest. Calendula became valued because it could be applied to chafed, minor damaged or inflamed skin in ways that many people found agreeable and comforting. That matters more than it first appears. Compromised skin can react badly to harsh substances, even if those substances are meant to help. A remedy that the tissue receives calmly can earn trust very quickly. Calendula's story is built on that trust. Salves, infused oils, and washes made from the flowers found their place because people observed that the plant could support fragile surfaces without making the problem feel louder. A garden flower became practical medicine by being accepted where the body was already struggling. Arnica is famous for bruises, though it should not be swallowed. This is one of those remedies that reveals how important route of use can be. Arnica became strongly associated with bumps, bruises, and sore areas because external preparations were believed to help with the aftereffects of minor trauma. Its reputation spread widely enough, but the flower started to feel almost synonymous with recovery after knocks and strains. Yet the same plant also teaches caution. Taken internally inappropriately, it can be toxic, which means its usefulness depends on respecting limits. That contrast is exactly what makes it so interesting. A remedy can be welcome on the skin and unsafe in the mouth. The plant does not become contradictory. We simply encounter it through different doors. Arnica belongs to that class of medicines that reward precision and punish carelessness. It reminds us that traditional use was often more exact than modern people assume. This was not a vague trust in nature. It was knowledge of where a plant belonged and where it did not. Comfrey was once called knitbone because people linked it with repair. Few herbal names are as vivid or as revealing. To call a plant knitbone is to say that people saw it as a companion to recovery, especially where the body had been damaged and needed mending. Comfrey earned that reputation because its roots and leaves were associated with soothing tissues and supporting the processes of repair. That old belief made the plant famous, yet the story has since become more complicated. Modern knowledge about certain compounds in comfrey has led to important safety concerns, especially for internal use. To me, that makes the plant even more fascinating, not less. It shows how a remedy can carry centuries of admiration and still require re-evaluation. Human beings noticed something compelling in its effects, enough to give it one of the most memorable names in herbal history. But medicine moves forward by testing old loyalties as well as preserving them. Comfrey stands at that crossroads where faith in healing meets the discipline of caution. Capsaicin from chili peppers can reduce pain by exhausting pain signals. At first, this sounds backwards. How could the fiery compound that creates burning become a treatment for pain rather than a cause of it? The answer is one of the strangest in plant medicine. Capsaicin strongly activates certain pain-sensing nerve fibers, and with repeated or controlled exposure, those fibers can become less responsive. In effect, the signal pathway gets overworked and quiets down. That is why capsaicin found a place in creams and patches used for some chronic pain conditions. The remedy begins by shouting, then leaves the nerves with less to say. There is something almost theatrical about that mechanism. A plant famous for heat ends up reducing suffering by pushing a sensory system to its limit. This is not soothing in the usual sense. It is strategic irritation, turned medicinal. That reversal is what makes it unforgettable. The burn is not the failure of the remedy. It is the doorway through which the remedy works. Even the sting of a pepper can become a pain remedy. The first encounter feels like the opposite of healing. Skin tingles, burns, and protests, which makes it hard to believe that anyone would ever look at a hot pepper and imagine medicine. Yet this is exactly what people and later clinicians did. They recognized that the fiery sensation itself could be harnessed. Applied in controlled ways, pepper-derived compounds can alter how certain nerve endings transmit discomfort, especially in long-lasting pain states where the nervous system has become overactive. That transformation is one of the great surprises in the whole story of plant remedies. The plant does not offer relief by being soft, cool, or comforting. It offers relief by temporarily intensifying sensation and then changing the system behind it. Few remedies teach us more clearly that healing does not always arrive in the form we expect. Sometimes the path to less pain runs through a carefully managed version of more. A burning fruit becomes a tool for turning volume down. Mustard plasters once warmed aching chests before modern rubs existed. There was a time when a congested chest, a hard cough, or the heaviness of winter illness called for remedies that worked through heat, circulation, and sensation. Mustard plasters were one of the most memorable. Ground mustard was mixed and spread onto cloth, then applied to the body to create a strong warming effect on the skin. The goal was not simply comfort. People believed that drawing heat to the surface could ease deeper tightness and help the chest feel less burdened. Whether used wisely or too aggressively, the experience would not have been forgettable. The skin reddened, warmth spread, and the remedy announced itself with force. What fascinates me is how physical old medicine often was. Before inhalers and manufactured chest rubs, households used plants to provoke the body into a different state. Mustard turned a kitchen ingredient into a dramatic treatment, blurring the line between spice, heat, and the feeling of breathing a little easier. Onion syrup was a home cough remedy in many kitchens. This remedy sits at the meeting point of practicality and tradition. Onions were common, cheap, and already present in the house, which meant they could move into the world of healing without ceremony. Sliced onions mixed with sugar or honey would slowly release liquid, creating a syrup that generations used for coughs and throat irritation. It sounds humble, almost improvised, yet that is part of its fascination. Home medicine often survived because it could be made from what people already had. The onion itself contained sulfur compounds and strong-smelling chemistry that gave it a long medicinal reputation, while the syrup form made it easier to take when someone was tired, hoarse, or ill. There is also something deeply human in the image. A kitchen becomes a pharmacy at night. A parent, grandparent, or neighbor prepares something simple because a cough is keeping someone awake. Not all remedies were exotic. Some lived in the vegetable basket. Honey is not a plant, yet flowers make it medicinally important. This is one of the loveliest detours in the story of plant remedies, because the medicine is made by an animal using plant chemistry as raw material. Bees gather nectar from flowers, transform it, and store a substance that humans have valued for food, preservation, and healing for thousands of years. Honey matters medicinally not only because it soothes throats and tastes comforting, but because it can inhibit microbial growth and support wound care under the right conditions. Its low water activity, acidity, and complex chemistry help explain that power. What makes it especially fascinating is that the character of honey partly reflects the floral world it came from. Meadow, forest, heather, orange blossom, and manuka all leave their mark. So when honey works as a remedy, the plants are still present within it, filtered through the labor of bees. It is a medicine made by pollination, flight, and flowers, then gathered into a spoon. Propolis owes part of its chemistry to tree resins gathered by bees. Bees do not only visit flowers. They also collect sticky resins from buds, bark, and plant wounds, then mix those materials with wax and enzymes to create propolis, a dark, aromatic substance they use inside the hive. It functions like a botanical sealant and defensive coating, helping protect the colony from microbial threats. Humans noticed that too. Propolis entered herbal and folk medicine because it carried the scent and apparent strength of tree resins into a concentrated bee-made form. What fascinates me is the chain of collaboration. A tree produces resin to defend itself. A bee gathers that resin for the hive. Then, humans harvest the result and use it medicinally. The remedy passes through 3 worlds: plant, insect, and human, before reaching the body. It feels almost alchemical, yet it is entirely natural. Propolis reminds us that healing substances do not always come straight from a leaf or root. Sometimes they arrive through another species first. Plant remedies often work best as complex mixtures, not isolated chemicals. Modern medicine often admires purity. One compound, one target, one measurable effect. Plants do not work that way. A medicinal leaf, root, or flower usually contains dozens or even hundreds of substances interacting at once. Some may provide the main action, while others alter absorption, reduce harshness, extend effects, or contribute benefits that are difficult to separate. That possibility has kept whole extracts interesting even in an age of purified drugs. The point is not that mixtures are always better. Sometimes purification is exactly what medicine needs. The point is that plants evolved as chemical communities, not single-molecule machines. When humans use a plant preparation, they may be entering a network of interactions rather than taking one active ingredient alone. That makes plant medicine harder to study, but also richer. A remedy can succeed not because one compound is doing everything, but because several are cooperating. In that sense, a plant extract may behave less like a bullet and more like an orchestra. Scientists still test whether whole extracts outperform a single purified compound. This question sits right at the frontier between traditional herbal practice and modern pharmacology. If a plant contains one famous active molecule, it might seem obvious that isolating that molecule would give the strongest and cleanest result. Yet biology is rarely that tidy. Researchers continue to test whether whole extracts sometimes perform differently or even better, because the surrounding compounds modify absorption, stability, side effects, or the overall pattern of action. That possibility is often called synergy, though proving it rigorously is difficult. What makes the question so fascinating is that it asks whether a plant can be more than the sum of its named parts. A laboratory may identify the star compound, but the supporting cast may still matter. This keeps old remedies scientifically alive rather than simply nostalgic. The challenge is not only to honor tradition or celebrate chemistry. It is to discover what the body actually responds to most effectively when a living plant becomes medicine. Some remedies smell strong because their active molecules evaporate into the air. That is one of the most immediate and dramatic ways plant chemistry reaches us. Many aromatic remedies contain volatile compounds, which means they escape easily into the air and enter the nose almost as soon as the plant is crushed, warmed, or steeped. This changes the whole experience of treatment. The remedy is no longer confined to what is swallowed or rubbed on the skin. It becomes part of the air around the body. That matters because inhalation is fast, intimate, and hard to ignore. The scent of mint, rosemary, lavender, eucalyptus, or thyme can fill a space before the mind has fully named it. In some cases, those evaporating molecules contribute directly to medicinal effects. In others, they shape perception, mood, and bodily response in ways that still matter. Either way, the fascinating truth remains. A plant can treat not only through touch or taste, but through atmosphere itself. Medicine can begin before the first sip. Essential oils are powerful because plants pack chemistry into tiny volumes. A whole field of aromatic plants can seem soft and harmless, yet much of its force is being stored in microscopic reservoirs. Essential oils are concentrated mixtures of volatile compounds that plants keep in glands, hairs, ducts, or secretory pockets. When those structures are crushed or distilled, an enormous amount of chemistry is released from a surprisingly small amount of material. That is why a few drops can smell overwhelming, sting skin, or rapidly alter the atmosphere of a room. The plant has spent energy making compact chemical defenses, signals, and protective agents. Then humans have learned how to gather them in concentrated form. What fascinates me is the scale of compression. A basket of leaves can become a tiny bottle with enough intensity to dominate the senses at once. It feels almost disproportionate, like a landscape being reduced to a liquid spark. In plant medicine, essential oils are a reminder that power does not need bulk. Sometimes it arrives as concentration. A single medicinal plant may contain hundreds of interacting compounds. When people imagine plant remedies, they often picture one famous ingredient doing all the work. Real plants are much stranger than that. Inside a leaf, root, or bark are layers of chemistry produced for defense, signaling, stress tolerance, attraction, storage, and repair. Some compounds are abundant. Others appear only in trace amounts. Yet even those smaller presences may matter because the body encounters the full chemical community, not just the most famous molecule on the label. One substance may change absorption. Another may soften irritation. Another may subtly extend or redirect the overall effect. That makes every medicinal plant feel less like a drug factory and more like an ecosystem in miniature. The fascination lies in that hidden complexity. A cup of herbal tea may carry a chemistry said too intricate to perceive by taste alone. What looks simple in the hand can become astonishingly crowded under analysis. The plant seems singular, but within it lives a whole society of molecules. Bitterness in a plant often signals chemistry with strong biological effects. The tongue is not only for pleasure. It is also a warning system shaped by long evolutionary experience. Bitter taste often signals the presence of alkaloids, glycosides, terpenes, and other compounds that can strongly affect living tissue. That does not mean every bitter plant is dangerous, or that every useful remedy tastes harsh, but it does explain why bitterness so often carries medicinal gravity. Traditional systems noticed this long before modern chemistry named the compounds involved. A mild herb might nourish. A bitter one might provoke digestion, stimulate secretions, or demand careful dosing. There is something thrilling about that first recoil in the mouth. The body is reacting before the mind has time to explain. It is as if human beings evolved to sense that some plants are not merely food. They are agents. That old bodily caution became part of medical knowledge. The taste itself offered a clue that the plant was capable of more than flavor, and possibly much more. Humans learned to taste caution, and sometimes that caution became medicine. Long before glassware, textbooks, or formal trials, the body was already helping guide human judgment. Taste, smell, burning sensations, and after effects all became part of a rough but meaningful language of plant discovery. A leaf that puckered the mouth, a root that turned sharply bitter, or a resin that left a numbing trace could all suggest that something biologically active had been encountered. Caution was the first response, and rightly so. Many plants can harm, yet over generations, that wariness slowly turned into discernment. People learned that not every unpleasant taste meant danger alone. Sometimes it meant potency waiting to be understood. A plant that was too forceful for food might still be useful in tiny amounts or specific preparations. That transformation is one of the most fascinating parts of herbal history. Human beings did not conquer nature by ignoring bodily warnings. They learned by listening to them, then asking whether the very thing that warned them might also heal. Willow bark tastes harsh because salicin was never made for us. It can be tempting to imagine medicinal plants as though they evolved kindly for human benefit, but willow tells a more honest story. Its bark contains salicin because the tree needed chemistry for its own life, its own defense, and its own interactions with the organisms around it. The harsh taste is part of that truth. The molecule was not crafted to be pleasant, and it was not designed as a gift for aching joints or feverish bodies. Humans simply discovered that once the bark entered our systems, that same chemistry could be useful. I find that beautiful because it strips away fantasy and replaces it with something deeper. Medicine was not waiting for us in a friendly form. We had to meet it where it lived, in bitterness, bark, and defense. A medicine now associated with modern relief began as a tree's strategy for being a tree. That is a far more astonishing origin than any romantic story could offer. Foxglove evolved cardiac glycosides to deter herbivores, not heal patients. When you stand before foxglove, the flowers seem almost theatrical. Tall spires hung with bells, inviting admiration rather than caution. Yet the plant's most medically famous compounds arose from a completely different purpose. Cardiac glycosides help defend the plant by making it dangerous to animals that might eat it. In the plant's world, that chemistry was a warning backed by consequences. Humans entered that story much later and discovered that, in exquisitely controlled amounts, those same compounds could influence the heart in clinically useful ways. What makes this so gripping is the moral reversal. A deterrent became a treatment. A biological threat became part of cardiology. There is nothing sentimental in that transformation. It is precise, risky, and intellectually thrilling. Foxglove reminds us that medicine often begins in hostility. The plant was not trying to help. We learned how to borrow from something built to say no. In doing so, we turned defense into therapy without changing its fundamental seriousness. Plants survive by chemistry, and medicine borrows from that botanical arsenal. A plant cannot flee a drought, outrun a fungus, or swat away a feeding insect. Its survival depends on chemistry woven into every part of its body. Some molecules repel grazers. Some harden surfaces. Some call in allies by scent. Others regulate growth, protect from light damage, or suppress invading microbes. Over millions of years, this has produced an immense library of biological strategies, written not in motion, but in molecules. Human medicine steps into that library and borrows. A compound that once shielded a leaf may later become a human drug. A resin meant to seal a wound in bark may suggest a therapy for tissue protection. What fascinates me is the continuity between those worlds. The hospital and the forest can look utterly separate, yet many medical breakthroughs are still rooted in that green chemical warfare. Plants do not survive by being passive. They survive by invention. Medicine advances when we learn to read those inventions and use them in our own bodies. Quinine once made tropical exploration far more survivable for outsiders. Before effective anti-malarial treatment, many tropical regions were deadly to newcomers in ways that reshaped history. The danger was not abstract. Fever could rise, the body could weaken rapidly, and repeated malaria infection could cripple expeditions, armies, and settlements. Quinine changed that balance. Derived from Cinchona bark, It gave outsiders a much better chance of surviving in places where malaria had already shaped local life for centuries. That single fact helped alter maps, voyages, and colonial ambitions. It did not erase disease, and it did not make tropical regions safe, but it changed the calculations of people who once would have been overwhelmed by mosquito-borne illness. The drama of that is extraordinary. A bitter bark from Andean forests became part of imperial logistics, naval movement, and the expansion of foreign power into environments that had resisted them. Few plant remedies have influenced both the body and global history so directly. Quinine did so with every swallowed dose of bitterness. Without Cinchona, the map of empires might have looked different. Disease has often decided history more powerfully than weapons, and malaria was one of its greatest forces. Large areas that seemed conquerable on paper became deadly in practice because outsiders could not reliably survive long enough to control them. Cinchona bark changed that equation by providing quinine, which helped protect and treat those who carried it into malaria-ridden regions. This did not create empire by itself, but it removed a crucial barrier. Colonizers, soldiers, traders, and administrators could remain in places that might otherwise have broken them with fever. That meant decisions made in faraway capitals suddenly had more chance of being enforced on the ground. What makes this so haunting is the asymmetry. A tree growing in one landscape ended up affecting power structures on multiple continents. History is full of grand narratives about ambition and conquest, yet sometimes the decisive factor is survival against a parasite. The borders on maps may owe as much to bark chemistry as to banners. Colonial botany often searched forests for cures as eagerly as gold. The image of empire usually centers on treasure, territory, and trade, yet plants were among the most coveted prizes of all. Colonial expeditions did not only map rivers and claim land. They also gathered seeds, dried specimens, local names, and medicinal uses with intense urgency. Forests were seen as storehouses of valuable chemistry, places where a new remedy might enrich a state, protect an army, or open commercial fortunes. This created a strange kind of extraction. Alongside timber, minerals, and labor, colonizing powers also sought biological knowledge. A root that eased fever, or a bark that countered infection, could become strategically important. That is what makes colonial botany so unsettling and fascinating. It was science, commerce, and power folded tightly together. Collectors moved through conquered landscapes not just looking for wealth in the ground, but for medicine in the understory. In that sense, the herbarium and the treasure vault were closer cousins than they first appear. Indigenous knowledge guided many discoveries long before formal science arrived. One of the deepest truths in the history of plant medicine is that many celebrated discoveries did not begin in laboratories. They began in communities that had lived with landscapes long enough to notice which plants soothed pain, reduced fever, quieted stomach trouble, or treated wounds. That knowledge was often practical, tested over generations, and embedded in daily life rather than published papers. When later researchers, traders, or colonists encountered it, they frequently gained leads they could never have generated so quickly on their own. This does not reduce scientific work. It clarifies its starting points. Formal science often entered a conversation already in progress. What moves me most is how much close attention must have been required. Someone had to observe, remember, compare, prepare, and teach. Entire traditions of care were built by people reading the land with precision. Modern medicine has benefited again and again from that intimacy with place, even when it failed to give proper credit for it. Some famous plant medicines were first preserved in oral traditions. Not every vital piece of medical knowledge began in writing. In many cultures, the earliest survival of plant wisdom depended on memory, repetition, story, apprenticeship, and spoken instruction. A remedy might be taught from elder to apprentice, parent to child, healer to community, with details carried in rhythm, ritual, and phrase. Which bark to gather, when to harvest, how long to boil, what taste signaled readiness, and which conditions called for caution could all live in the spoken world long before a botanist ever arrived with a notebook. That makes oral tradition far more than folklore in the dismissive sense. It was an archive, disciplined by usefulness and continuity. The fragility of it is part of what makes it so powerful. If the chain of speaking breaks, the remedy can vanish without leaving a page behind. Some of the world's most important plant medicines may have survived precisely because human voices kept repeating them until science finally caught up. Losing a language can mean losing medical knowledge hidden within it. A language does more than name a plant. It can encode where that plant grows, what season matters, which part is safe, how it is prepared, and what bodily experience it belongs to. One word may imply bitterness, heat, caution, ritual context, or relationship to another species. When such a language disappears, those meanings do not always transfer cleanly into a dominant tongue. A plant may survive in the forest and still become medically invisible because the web of understanding around it has been severed. That is what makes language loss so devastating in the history of remedies. It is not only a cultural tragedy, it can also be a biological one. A cure, a treatment clue, or a preparation method may vanish without anyone realizing what was lost. I find that haunting. Entire pharmacologies may have been carried in pronunciation, metaphor, and memory. When the last fluent speakers go silent, a forest may become quieter to science than it was before. Rainforests are pharmacies partly because competition drives plants to innovate chemically. A rainforest is crowded life. Vines climb, insects chew, fungi spread, roots compete, and leaves struggle for light in one of the most contested environments on Earth. In such a place, chemistry becomes survival technology. Plants must deter herbivores, resist infection, attract the right pollinators, and negotiate with surrounding organisms, all while living in heat and moisture that favor constant biological attack. That relentless pressure helps explain why rainforests hold such extraordinary chemical diversity. Each plant lineage is solving problems, and many solutions take molecular form. To walk through a rainforest, then, is to move through an immense living laboratory where millions of experiments have been running for evolutionary ages. That is why bioprospecting has so often focused on these regions. The richness is not random. It is driven by competition. When life presses close on every side, plants respond by becoming chemically inventive. Their molecules are not decorative extras. They are strategies sharpened by a crowded world. Desert plants also make unusual compounds because survival there is extreme. Rainforests are not the only chemical frontiers. Deserts push plants into a completely different kind of creativity. Water is scarce, sunlight can be brutal, temperatures swing wildly, and growth must often happen in brief windows of opportunity. In that harsh setting, plants evolve compounds that help protect tissues from dehydration, ultraviolet damage, oxidative stress, and hungry animals desperate enough to eat almost anything green. Some desert species store moisture, some harden themselves with spines and waxes, and many quietly manufacture chemistry that lets them endure where softer forms of life would fail. What fascinates me is that these landscapes can look barren from a distance, yet their plants may be among the most chemically remarkable on Earth. Scarcity has a way of intensifying strategy. A desert herb does not merely live with hardship. It is built by it. That makes arid environments surprisingly rich places to search for unusual plant remedies, each one forged under pressure and sun. High mountain herbs endure stress that can intensify their chemistry. At altitude, life becomes harder in subtle and relentless ways. The air is thinner, temperatures are lower, winds can be fierce, soils are often poor, and ultraviolet radiation strikes with greater intensity. For a plant, that combination can be punishing. Yet many mountain herbs do not merely survive there. They respond by producing dense arrays of protective compounds, pigments, aromatics, and antioxidants that help them endure their exposed world. This is one reason alpine plants have such strong medicinal reputations in many traditions. Their chemistry may be intensified by the very conditions that threaten them. I find that deeply compelling because it turns harshness into concentration. A herb growing slowly on a high slope may be chemically more dramatic than the same species in gentler ground below. The mountain is not only a place of beauty, it is also a pressure chamber. In those thin, bright environments, medicinal potential may rise not despite the stress, but because of it. Harsh sunlight can push medicinal plants to make stronger protective molecules. Sunlight is life-giving, but too much of it becomes a form of attack. Intense light, especially ultraviolet radiation, can damage plant tissues, proteins, pigments, and DNA. To survive, plants respond by making protective compounds that absorb light, quench reactive molecules, and reinforce vulnerable surfaces. Many of those same compounds later interest humans because they can have antioxidant, anti-inflammatory, or otherwise biologically active properties. That makes a bright hillside more chemically dramatic than it appears. A plant standing under relentless sun is not simply basking. It is defending itself every day. The result may be deeper color, stronger aroma, more bitterness, or a more potent medicinal profile. What fascinates me is how environmental hardship becomes molecular richness. The stronger the light, the more urgently the plant may need to protect itself, and the more interesting its chemistry may become. In that sense, blazing sunlight is not only growing the plant, it is helping write the remedy within it. Soil, season, and altitude can all change a remedy's chemistry. Two plants with the same name can lead very different chemical lives depending on where and when they grow. Soil minerals, moisture, microbial partners, temperature swings, day length, and elevation all influence what a plant makes and how much of it accumulates. A medicinal herb grown in rich lowland soil may not match the aroma, bitterness, or potency of the same species gathered from stony uplands. Even within one location, the plant can shift across the year as growth, flowering, seed production, and stress alter its internal priorities. This is one reason traditional herbalists were often so specific about place and season. They were not being quaint. They were tracking chemistry through lived observation. What fascinates me is how unstable the idea of a remedy becomes once you see this clearly. The plant is not a fixed object. It is a response to environment. Change the conditions, and you may change the medicine hidden in its tissues. The same species may not make the same remedy everywhere. That truth unsettles the comforting idea that a plant is always medically identical wherever it appears. In reality, the chemistry of a species can vary from region to region so strongly that one population may smell different, taste different, or produce different levels of its most valued compounds. Climate, altitude, day length, soil, drab stress, local pests, and even genetics within the species can all shape what the plant becomes in chemical terms. This means that a remedy trusted in one valley might not perform in quite the same way when grown on another continent. For medicine, that is a profound complication. It means identity is not only botanical, it is ecological. What fascinates me is how much place matters. A species name can make two plants seem equivalent on paper, while the landscape has been quietly rewriting their chemistry all along. The remedy is not just the plant. It is the plant and its environment, carrying the fingerprint of where it lived. Harvest timing can decide whether a medicinal plant is weak or potent. A plant is not chemically static. It changes across the day, across the season, and across its own life cycle. Leaves may be richest in certain compounds before flowering, roots may concentrate reserves after the top growth dies back, and flowers may lose key aromatics if gathered too late. Even morning versus afternoon can matter for some species, especially when volatile oils rise and fall with heat and light. This is why harvest instructions became so exact in traditional practice. Gather too early, and the plant may still be building what you want. Gather too late, and the prized chemistry may have faded, shifted, or been spent on seed. That makes harvesting feel less like collecting and more like timing an encounter. The remedy exists in a window, and skill lies in finding it. I love that idea because it adds tension to the process. The plant is ready only at certain moments, and medicine depends on noticing when. Drying a plant can preserve some compounds and destroy others. The moment a medicinal plant is cut, its chemistry begins to change. Water leaves the cells, enzymes start breaking substances apart, and delicate aromatic molecules may drift off into the air before anyone notices. Yet drying is not simply loss. For some remedies, it is preservation. It stops rot, slows microbial damage, and stabilizes compounds that might otherwise vanish in fresh material. That is why herbal traditions became so exact about shade, airflow, temperature, and timing. A leaf dried too hot might lose its scent and part of its power. A root dried too slowly might mold before it can be stored. What fascinates me is that the remedy is still alive in a sense, chemically active and changing, even after harvest. A hanging bundle in a loft is not just a plant becoming crisp. It is a transformation chamber. Some medicines are improved by that quiet change, while others are weakened by it, and skill lies in knowing which is which. Heat can transform a remedy before it ever reaches the cup. A kettle does more than warm water. It can reshape medicine. The moment heat touches a leaf, bark, or seed, compounds begin to shift. Some dissolve more easily. Some break apart. Others become available only because hot water has opened the cells that trap them. This is why a remedy prepared as a hot infusion may not act like the same plant eaten raw or soaked cold. Heat can soften bitterness, release fragrance, and change the body's experience from harshness to comfort. It can also ruin what is fragile. Certain volatile oils disappear quickly, and some delicate constituents do not survive the long simmer. That tension makes the teacup more interesting than it looks. Brewing is chemistry in motion. The choice of hot or warm, brief or prolonged, can decide which version of the plant finally arrives in the body. In that sense, preparation is never neutral. Fire becomes part of the remedy before the first sip. Fermentation has sometimes made plant remedies easier for the body to use. Fermentation can feel like controlled decay, yet it often turns out to be transformation with purpose. When microbes act on plant material, they do not merely preserve it or alter its flavor. They can break down tough compounds, reduce certain irritants, and create forms the body handles more easily. That is why fermented plant preparations have appeared in many healing traditions, sometimes as tonics, sometimes as food medicines, and sometimes as more complex herbal products. The plant enters one state and leaves another, shaped by bacteria or yeast that act like invisible chemists. What fascinates me is the partnership. Humans learned not only from the plant itself, but from what happened when life worked on life. A harsh root might become more digestible. A useful compound might become easier to absorb. The remedy becomes less fixed and more alive. Fermentation reminds us that medicine does not always come straight from the field. Sometimes it passes through another world first. Roasting, boiling, steeping, and tincturing all pull different chemistries forward. A plant is not a single note waiting to be played. It is more like an instrument that sounds different depending on how it is handled. Roast a root and you may deepen certain flavors, soften harshness, or alter irritating compounds. Boil bark or dense roots, and you can draw out heavier constituents that hot water needs time to reach. Steep leaves and flowers briefly, and you preserve lighter aromatics that long heat might drive away. Place herbs in alcohol, and an entirely different set of compounds moves into solution, including many that water alone would leave behind. This is why preparation methods matter so much in herbal medicine. They do not simply package the plant. They select from it. Each method asks a different question of the same material, and each receives a different answer. What reaches the body depends as much on the liquid, time, and heat as on the herb itself. Technique shapes chemistry before chemistry shapes us. A tea, tincture, poultice, and capsule can behave very differently. It is easy to imagine that the plant matters, and the form does not. But the form can change almost everything. A tea reaches the body in warmth and water, often acting quickly in the digestive tract or through inhaled steam rising from the cup. A tincture delivers concentrated compounds in alcohol, sometimes in a way that absorbs faster or preserves longer. A poultice bypasses the stomach entirely and brings the plant straight to skin or tissue where local effects matter most. A capsule may hide taste, slow perception of the remedy, and make the experience feel more clinical even when the plant inside is the same. This fascinates me because it shows that remedies do not travel to the body as abstract chemistry. They arrive through a root, a texture, a pace, and a ritual. The body meets not just the herb, but its presentation. Change that presentation, and you may change the whole conversation between plant and person. Some remedies work on skin but become risky when taken internally. The human body is not one continuous surface with one consistent set of rules. Skin can tolerate substances that the digestive system, liver, or heart would read very differently. That is why some plant remedies are useful when applied externally, but unsafe when swallowed. The skin may receive them as local warmth, soothing, stimulation, or mild irritation, while the inside of the body may face toxicity, stronger absorption, or effects on vital organs. Traditional medicine often understood this with surprising precision. A salve might be trusted, while the same plant in a tea would be avoided. What fascinates me is how this changes the idea of what a remedy is. The plant itself has not changed. What changes is the doorway. One root keeps the effect near the surface. Another invites the chemistry into blood, metabolism, and deeper systems. A remedy can therefore be acceptable in one form and dangerous in another, which makes knowledge of root as important as knowledge of species. Others are harmless to swallow, yet irritating on the skin. Some plants reveal the opposite pattern, and that reversal is just as fascinating. A tea or food made from a particular herb may pass through the body without trouble, yet the fresh sap, hairs, or concentrated oils from that same plant can sting, redden, or inflame the skin on contact. This happens because skin is not merely a wrapper around the body. It is a highly responsive organ with its own barriers, nerve endings, immune reactions, and vulnerabilities. What the stomach can dilute or metabolize the skin may experience as an immediate assault. Think of how certain citrus peels, spice oils, or raw plant juices can irritate bare hands even though their culinary use is completely ordinary. That split in behavior makes plant remedies more interesting and more demanding. Safety is not a simple label attached forever to a species. It depends on context, concentration, and contact. The body asks different questions at the surface than it asks within. Stinging nettles can hurt on contact and still be used medicinally. This plant is a perfect lesson in botanical contradiction. Brush against fresh nettles and the hairs on the leaves and stems act like tiny needles, injecting irritating compounds that produce burning, redness, and a memorable sting. It feels like a warning, and in one sense it is. Yet the same plant has been valued in herbal medicine and food traditions for generations. Once properly handled or cooked, nettles lose their sting and reveal a very different identity, one associated with nourishment, toning, and a range of traditional uses. That transformation is what makes them so captivating. A plant that punishes touch can become a valued tea, soup ingredient, or remedy in the right hands. It reminds us that medicinal knowledge often begins by learning how to cross a plant's defenses. The sting is not the whole story. It is the gate. Beyond it lies a species that people kept returning to, even after it had already announced itself with pain. Nettle leaves also carry a long history in traditional spring tonics. After long winters, many traditions looked for ways to awaken the body, restore appetite, and bring fresh green vitality back into daily life. Nettle became one of the great plants of that moment. Young leaves, gathered carefully and prepared properly, were used in soups, broths, teas, and tonic preparations that marked the shift from scarcity toward renewal. This was not only symbolic. Early spring foods mattered deeply when diets had grown repetitive and limited. A plant that arrived fresh, mineral-rich, and strongly green would have felt like medicine, even before anyone tried to explain it scientifically. What fascinates me is how closely season, body, and remedy came together. Nettle was not just an herb taken at random. It belonged to a time of year when people felt the need to clear heaviness and begin again. The plant became part of a cultural rhythm of recovery. It was one of the first living signs that the land was feeding the body anew. Dandelion became a remedy because people noticed how widely it acts. This plant is almost impossible to ignore, and that may be part of why people learned so much from it. Dandelion grows in disturbed ground, lawns, roadsides, meadows, and gardens, appearing with such persistence that generations had constant opportunity to test it. Over time, people noticed that different parts seemed to act in different ways. Leaves were linked with fluid balance and digestion. Roots entered traditions involving appetite, the liver, and tonic use. Even the bitter taste itself suggested activity. What makes dandelion fascinating is its breadth. It is not a glamorous rarity from a distant forest. It is an everyday plant that kept proving useful enough to earn attention. That changes the way you see it. A weed becomes a medicine chest spread across common ground. The story also reveals something important about herbal discovery. People do not always need remote jungles to find remedies. Sometimes a plant becomes famous because it is always there, waiting to be taken seriously. Burdock root entered herbal medicine through both food and healing traditions. Some plants never sit neatly in one category. Burdock is one of them. Its long root has been eaten as food in parts of the world, yet it also developed a reputation as a medicinal plant, especially in traditions concerned with digestion, the skin, and gradual bodily support. That dual identity matters. When a plant lives in both the kitchen and the apothecary, people come to know it differently. They do not only measure it by dramatic symptom relief. They experience it as something that can nourish while also influencing the body's internal balance. Burdoc's earthy taste and substantial root give it a grounded quality that suits that role. It feels less like a quick intervention and more like a deep plant, one associated with patience and slow work beneath the surface. I find that compelling because it shows how medicine and food often overlap. Sometimes the most enduring remedies are the ones humans trusted enough to place on the table. Milk thistle became famous for compounds that protect liver cells. This plant looks armed for defense, all spines and striking white-veined leaves. Yet the story that made it famous unfolds inside one of the body's most vital internal organs. Milk thistle drew intense attention because of a group of compounds called silymarin, which became associated with protection of liver cells and support during certain kinds of liver stress. That gave the plant a reputation unlike many other herbs. It was not chiefly about soothing a throat or easing a stomach in the moment. It was about guarding an organ that works silently and constantly, filtering blood, processing chemicals, and shouldering an immense metabolic burden. What fascinates me is the contrast. A prickly plant growing in rough places became linked with one of the body's great biochemical engines. The symbolism almost fits too well. A defended plant offering defense. Over time, that idea gave milk thistle an unusually strong place in both herbal tradition and modern supplement culture. Ginkgo leaves inspired research into circulation and cognitive aging. The tree itself already feels ancient before medicine enters the story. Ginkgo is a botanical survivor, a lineage so old it seems to carry deep time in its fan-shaped leaves. When those leaves entered modern research, attention focused on their possible effects on circulation, especially in small vessels, and on aspects of memory and cognitive aging. That does not make the evidence simple, but it does make the plant immensely intriguing. A tree that endured across geological ages became associated with the human fear of decline, forgetfulness, and fading mental sharpness. The emotional force of that is powerful. People do not only take interest in circulation as an abstract function. They care because it touches clarity, energy, and the experience of remaining mentally present as years pass. Ginkgo's medicinal story therefore feels larger than one herb. It connects ancient survival in nature with one of the most intimate modern worries, how the mind changes when time keeps moving. St. John's wort can affect mood and also many prescription drugs. This plant is one of the clearest examples of why herbal medicine can never be reduced to the idea that natural means mild. St. John's wort became widely known because it appeared to influence mood in some cases, which made it deeply attractive to people seeking plant-based support for emotional heaviness. Yet the same chemistry that gives it that significance can also alter how the body processes many prescription medicines. It can speed up certain metabolic pathways in the liver and intestines, which may reduce the effectiveness of drugs ranging from contraceptives to transplant medications. That makes the plant both compelling and sobering. Here is a flower that can touch mental state and pharmaceutical balance at the same time. It belongs not only to herbal history, but to the modern world of complex interactions. What fascinates me is how clearly it exposes the power of plant chemistry. A yellow blossom can change not just how someone feels, but how medicine itself behaves. Grapefruit is not an herbal remedy, yet it alters drug metabolism profoundly. This fruit usually enters the story of medicine almost by surprise. People think of breakfast, juice, or bitter freshness, not pharmacology. Yet grapefruit contains compounds that can interfere with enzymes in the gut responsible for breaking down many drugs before they enter circulation. When those enzymes are blocked, certain medicines can reach unexpectedly high levels in the bloodstream. That means a perfectly ordinary fruit can change the dose the body effectively receives without anyone touching the prescription itself. I find that astonishing because it collapses the boundary between food and medicine in a very modern way. You can follow every instruction on a bottle and still alter the outcome with what seems like a harmless part of breakfast. Grapefruit therefore belongs in the wider story of plant remedies, even though no one is taking it as one here. It reminds us that the body reads chemistry, not intention. A fruit can become pharmacologically important simply by arriving at the wrong moment. Plant remedies can clash with medicines because the liver reads chemistry literally. The liver is not impressed by labels like herbal, natural, prescription, or traditional. It does not care what a substance is called or why a person took it. It encounters molecules and begins processing them through enzyme systems that determine breakdown, activation, storage, and removal. That is why plant remedies can interact with medicines in ways people do not expect. A herb may speed up metabolism, slow it down, compete for transport pathways, or place extra demand on an already busy detoxification system. The clash happens not because the body is confused, but because it is precise. It reads chemistry, literally. What fascinates me is how that changes the conversation around safety. The danger is not only in obviously toxic plants. It can also lie in ordinary seeming combinations that alter timing, concentration, and effect. The liver becomes the meeting ground where traditions, modern drugs, food compounds, and supplements all arrive together and must somehow be sorted. Natural does not mean simple, gentle, or automatically safe. This may be the most important correction in all of plant medicine. Nature produces nourishment, fragrance, beauty, and healing. But it also produces paralysis, hallucination, organ damage, convulsions, and death. Plants evolved chemistry to survive, not to reassure us. Some remedies are mild and appropriate. Others are potent enough to demand exact preparation and expert knowledge. Even familiar herbs can be risky in pregnancy, in childhood, alongside medication, or at high doses. The idea that natural always means kind is therefore not only false, it is dangerous. What fascinates me is that the truth is far more interesting than the myth. Plants are powerful precisely because they are not simple. They act on bodies because their molecules matter. Respect is the right response, not blind trust or blind fear. The forest is not a pharmacy because everything growing there is safe. It is a pharmacy because so much of what grows there can truly change us. Some of the deadliest plants on Earth also shaped medicine. There is no clean line separating poison from remedy. In fact, some of the most influential medicines emerged from plants that could kill if mishandled. That unsettling truth runs through the history of pharmacology. Certain species evolved compounds so powerful that they disrupt the heart, nervous system, vision, breathing, or muscle control with terrifying efficiency. Yet in measured doses, purified forms, or carefully controlled settings, those same compounds sometimes became tools for healing. What makes this so gripping is that it refuses the comforting idea that medicine must come from gentle sources. Often it comes from the edge of danger. The same plant that could end a life in the wild might later help a surgeon, a cardiologist, or an emergency physician. That does not make the plant benevolent. It makes human knowledge daring. We learn to approach lethal chemistry with precision and use part of it without unleashing the whole. In medicine, some breakthroughs begin in fear. Deadly nightshade taught doctors as much about danger as healing. Belladonna has one of the darkest reputations in herbal history, and deservedly so. Its berries can look inviting, yet the plant contains tropane alkaloids that can produce a frightening mix of dry mouth, rapid heartbeat, dilated pupils, delirium, hallucinations, and potentially fatal. Toxicity. For physicians and herbal practitioners, it became a hard teacher. It showed how profoundly plant chemistry could alter the nervous system, and how thin the line between observed effect and disaster could be. Yet from that danger came knowledge. By watching what such plants did to the body, doctors learned more about pupils, secretions, smooth muscle, and nerve signaling. The plant became not only a warning, but a window into physiology. What fascinates me is that its educational power came through risk. Belladonna did not politely offer information. It forced it. The lesson was severe, but unforgettable. Some plants entered medicine not as trusted companions, but as formidable instructors in what the body could endure. Atropine from belladonna still has important medical uses today. One of the most striking things about plant medicine is how often an old danger becomes a modern tool. Atropine, derived from belladonna and related plants, remains medically important because it can block certain nerve signals in ways that doctors can use with precision. It has roles in emergency care, in treating some poisonings, in certain heart-related situations, and in eye medicine, where pupil dilation is needed. That range is astonishing when you remember the plant it came from. A chemistry once feared in hedgerows and herbals now sits in clinical settings under exact dosing and careful indication. This is the transformation plant medicine achieves at its most dramatic. It does not erase the danger. It learns how to direct it. What fascinates me is the continuity across centuries. The same fundamental compound still acts on the same human physiology, yet our relationship to it has changed completely. A lethal lesson from an old plant became a controlled instrument in modern care. Opium poppies changed pain medicine long before chemistry named morphine. For most of human history, severe pain was one of life's great terrors. Injury, surgery, childbirth, and disease could bring agony with very little to stop it. Then came the opium poppy, a plant whose milky sap held compounds powerful enough to dull suffering in a way earlier remedies rarely could. Long before anyone isolated morphine or understood receptors in the nervous system, people knew this flower could quiet pain, bring sleep, and alter consciousness profoundly. That knowledge changed medicine, though it also opened the door to dependence, misuse, and sorrow. What makes the poppy so extraordinary is the scale of its influence. A delicate blossom growing in a field helped shape surgery, warfare, trade, and the entire human relationship with pain relief. Few plants have ever held so much mercy and danger in the same capsule. Its legacy is not simple, but it is impossible to ignore. Medicine still lives in its shadow. Coca leaves inspired local remedies and later, powerful modern anesthetics. High in the Andes, coca leaves were used for centuries in ways deeply tied to place, labor, altitude, and the body's limits. People chewed them to ease hunger, fatigue, and the strain of thin mountain air. That alone would make the plant fascinating, but its story did not stop there. The chemistry within coca eventually led scientists toward compounds that revealed something astonishing, that certain plant molecules could numb nerves with remarkable precision. From that line of discovery came major advances in local anesthesia, which transformed dentistry, surgery, and countless medical procedures. What began as a leaf used in daily life under extreme conditions helped unlock a way to block pain without putting the entire body to sleep. That is a huge leap. A mountain remedy became part of modern operating rooms. The journey was complicated and often ethically tangled, yet the scientific importance remains clear. Few plants have influenced both endurance and anesthesia so directly. Ephedra shaped the history of breathing medicines and stimulant drugs. Some plants became medically famous because they touched the most urgent functions of the body, and breathing is among the most urgent of all. Ephedra earned its place because it contains alkaloids that can open airways, stimulate the heart, and sharpen alertness. In traditional medicine, it was used in forms aimed at respiratory distress and related conditions. Later, its chemistry helped shape the development of drugs used for asthma, nasal congestion, and stimulation. What makes the plant so gripping is how directly its effects can be felt. This is not a subtle shift. It is a change in pressure, pace, and readiness. The chest feels less trapped. The body feels more awake. That immediacy is exactly why the plant became both useful and controversial. A remedy that can move the body so strongly will always demand caution. Ephedra sits at the crossroads of relief and overdrive, where medicine meets the body's raw emergency systems. A cancer drug from mayapple works by stopping cells from dividing. At first glance, mayapple hardly looks like a plant with such serious medical consequences hidden inside it. It grows low to the forest floor, with umbrella-like leaves and a pale fruit that seem almost modest. Yet from this woodland plant came compounds that helped lead to major cancer drugs. The medical importance lies in their ability to interfere with cell division, which is exactly what makes many cancers so dangerous. Tumor cells do not respect limits. They keep multiplying. Chemistry derived from mayapple helped create medicines that can interrupt that process and slow the spread of disease. What fascinates me is the contrast in scale. A small plant from shaded ground ended up influencing one of the largest and most frightening categories of illness humans face. The forest floor becomes a place of consequence. A quiet native plant becomes part of chemotherapy. It is one more reminder that the size of a plant tells you almost nothing about the size of its medical impact. Taxol from yew helped prove trees could hide life-saving molecules. There is something almost unbelievable about the idea that a slow-growing tree could contain chemistry capable of changing cancer treatment, yet that is exactly what happened. The Pacific yew was once treated as a background species, not especially celebrated, often overlooked among larger and more commercially useful trees. Then researchers found Taxol within it, a compound that interferes with the machinery cells used to divide. That discovery mattered enormously because it gave medicine another weapon against fast-growing cancers. It also changed the way people thought about the plant world. Trees were not just timber, shade, or symbols of longevity. They could also be sources of highly sophisticated molecular strategies with direct clinical importance. The yew seemed to hold a secret almost no one had thought to ask for. That is what makes the story so thrilling. A species standing silently in the forest turned out to be part of a revolution in cancer care. The search for remedies often begins with plants under attack. A healthy leaf can be interesting, but a damaged one may be even more revealing. When plants are chewed, infected, cut, or stressed, they often change their chemistry rapidly, producing defensive compounds, warning signals, or protective substances that were absent or much weaker before the attack. For scientists and traditional observers alike, that makes wounded plants a rich place to look for medically important molecules. The logic is beautifully simple. A plant facing danger must solve a biological problem immediately, and the solution is often chemical. If a fungus lands, the plant answers. If an insect bites, the plant answers. That means the moment of attack may reveal the plant's most active and creative chemistry. What fascinates me is that medicine can begin not in calm abundance, but in crisis. A remedy may first appear because something tried to eat, infect, or injure a plant. Human healing sometimes starts by watching how the green world defends itself. When a leaf is wounded, its chemistry can change within minutes. Plants may appear motionless, but injury proves how responsive they really are. The instant a leaf is torn or bitten, a wave of signaling begins. Electrical changes move through tissues. Hormones rise. Enzymes switch on. Molecules that were stored separately may suddenly combine into new defensive chemistry. All of this can happen astonishingly fast, sometimes within minutes, as though the plant has recognized an emergency and activated a hidden protocol. That speed is one of the most mind-changing things in plant science. It reveals a living system that senses damage and reorganizes itself almost immediately. For medicine, this matters because those rapid response compounds may be exactly the ones with interesting biological effects for humans. A wounded leaf is not merely dying at the edges. It is becoming chemically louder. What fascinates me most is the drama of the moment. A bite from an insect can trigger a molecular storm, and that storm may contain clues to entirely new remedies. Some plants call for help by releasing airborne distress chemicals. A plant under attack is not always silent. In many cases, it releases volatile compounds into the air, and those compounds can do remarkable things. They may warn nearby leaves on the same plant to prepare defenses. They may alert neighboring plants of the same species. Most astonishing of all, some can attract predatory insects that attack the herbivores doing the damage. In other words, a chewed leaf can send out a chemical signal that summons reinforcements. That feels almost unbelievable until you realize it is simply another form of survival through chemistry. For medicine, this matters because such airborne signals are part of the wider chemical intelligence of plants, and they may lead us toward new compounds and new ways of thinking about biological communication. What fascinates me is the sheer drama. A caterpillar takes a bite, and the plant answers by changing the atmosphere itself. The air becomes a message, and the message can change the outcome. Medicinal chemistry sometimes begins with a plant trying not to be eaten. That may be the most elegant summary of the entire field. So many medically useful compounds were not created as nutrients, gifts, or accidents. They were evolved as defenses. A plant needed to survive insects, grazing animals, fungi, or bacteria, so it made molecules that taste awful, disrupt digestion, damage nerves, slow growth, or kill invaders outright. Humans later encountered those same compounds and realized they could act on our own biology in controlled and useful ways. That reversal is what makes plant medicine so profound. Healing often begins in refusal. The plant is saying, "Stay away," and we answer by studying how that warning works. Then, with enough care and knowledge, we sometimes turn it into a treatment. What fascinates me is how unsentimental nature is. The chemistry was never meant to comfort us. Yet some of our best medicines emerged from exactly that indifference. A plant's struggle to avoid becoming lunch became part of human pharmacology. Scientists now use artificial intelligence to hunt for new plant remedies. The search for medicinal plants once depended almost entirely on fieldwork, oral knowledge, and patient laboratory testing. Those still matter deeply, but now another tool has joined them. Artificial intelligence can sift through huge chemical datasets, compare molecular structures, predict biological targets, and suggest which plant compounds might be worth studying first. That does not mean a computer replaces the forest or the lab bench. It means the search becomes sharper. Instead of testing everything blindly, researchers can use models to spot promising molecules hidden in vast libraries of plant chemistry. What fascinates me is the meeting of ancient and modern here. One end of the story is a leaf, a root, a tradition, a habitat. The other end is machine learning, pattern recognition, and computational screening. Between them lies the possibility of discovering treatments faster than before. A future drug may be found because a machine noticed a pattern in plant chemistry that no human eye could hold all at once. DNA tools can reveal which species are really inside herbal products. Once a plant has been dried, powdered, chopped, pressed into tablets, or blended into capsules, it can become surprisingly hard to identify by sight alone. That matters because the wrong species can make a remedy ineffective, contaminated, or dangerous. DNA analysis has changed this problem dramatically. With modern genetic tools, scientists can test samples and identify which plant species are actually present, even when the original leaves or roots are no longer recognizable. That is a profound shift for quality control. The label may promise one herb, but DNA can reveal substitutions, fillers, or accidental mix-ups. What fascinates me is how this turns genetics into a kind of forensic botany. A capsule becomes a crime scene for truth. The technology does not make herbal medicine less traditional. It makes the claims around it more testable. In a field where species identity matters enormously, DNA offers something priceless, a way to ask the plant itself who it really is. Ancient remedies are now being retested with modern clinical methods. This is one of the most interesting chapters in the story of plant medicine, because it refuses both blind faith and easy dismissal. Remedies once trusted because of long use are now being examined with randomized trials, standardized extracts, placebo comparisons, and careful outcome measures. Some perform better than expected. Others turn out to be weaker, narrower, or more variable than tradition suggested. Either way, the process matters. It allows medicine to ask not only whether a remedy has history, but whether it works under modern scrutiny and for which conditions. What fascinates me is the dignity of that encounter. An old remedy does not have to stay trapped in nostalgia. It can step into a clinical trial and be tested on the same terms as other treatments. That gives the story forward motion. The past is not simply preserved. It is questioned, measured, and sometimes vindicated. Ancient medicine keeps living by being asked new questions. Some herbal traditions survive because careful trials confirmed parts of them. Traditional use can preserve a remedy for centuries, but in the modern world, survival often depends on something else as well. Evidence that holds up when formally tested. A number of herbal practices remain widely respected, not because people refused to question them, but because research confirmed that at least part of the old reputation was deserved. Sometimes the full traditional story narrows into a more specific medical use. Sometimes a broad claim becomes a modest but real benefit. That kind of confirmation is powerful because it builds a bridge between experience and experiment. What fascinates me is that this is not victory for one side over the other. It is a meeting point. The healers were not always wrong. The laboratory is not always hostile. In the best cases, careful trials reveal that a long-used plant truly does something meaningful, and the ancient intuition behind it becomes part of evidence-based medicine instead of being left behind. Others fade when science shows the old claims were mistaken. Not every inherited remedy survives examination, and that is not a failure of science. It is one of its great acts of care. Some plants, long praised for dramatic effects, turn out, under controlled testing, to do far less than people hoped. Others seem inconsistent, working only in narrow circumstances or not outperforming placebo in meaningful ways. That can feel disappointing, especially when a remedy carries centuries of reputation behind it. Yet there is something admirable in letting evidence correct tradition. It protects patients from wasted time, false hope, and avoidable risk. What fascinates me is that this process does not diminish the past so much as clarify it. A plant may have been comforting, symbolic, or useful in a context that no longer applies, even if it was never the strong cure people believed. Science does not only discover what works, it also reveals where stories grew larger than the medicine itself, and that honesty matters. Plant medicine is a meeting place between folklore, ecology, and pharmacology. Very few subjects draw such different worlds together. Folklore brings memory, story, ritual, and the long human habit of passing remedies through generations. Ecology explains why plants make the molecules they do, because every medicinal compound began as part of a living relationship with insects, sunlight, microbes, drought, or competition. Pharmacology then steps in to ask what those molecules do inside the human body, how they are absorbed, what targets they affect, and where safety begins or fails. What fascinates me is that none of these worlds is enough on its own. Remove folklore, and you lose many of the clues. Remove ecology, and you forget why the plant made the chemistry at all. Remove pharmacology, and you cannot test or refine what the body actually experiences. The field becomes richest when all three remain in view. Plant medicine is not simply old wisdom or modern science. It is the place where both are forced to talk. Every forest still contains molecules no human medicine has studied. That fact should permanently change the way a woodland feels. Every tree trunk, vine, mossy edge, and patch of understory may contain compounds no one has isolated, tested, or even named. We know enough about plant diversity to be certain of this. The chemical richness of forests is so vast that human research has only sampled a fraction of what is there. Some molecules may do nothing useful for us. Others may become the starting point for future antibiotics, anti-inflammatory drugs, anti-cancer agents, or entirely new categories of treatment. What fascinates me is the scale of the unknown. We walk through forests imagining them as familiar landscapes, yet they are still full of unasked chemical questions. The great age of discovery is not over. It may be standing quietly under branches, waiting for a scientist, a healer, or a curious mind to notice. A forest is not only habitat, it is also unread pharmacology. Extinction may erase remedies before anyone even knows they exist. This is one of the saddest truths in the whole subject. A plant species can disappear without ever having been chemically studied, medically tested, or even fully described. If that species carried a useful compound, the loss is permanent. Not delayed, not theoretical, permanent. Extinction does not only remove a beautiful organism from the earth, it closes a library before anyone has learned the language inside it. What makes this especially haunting is how many medically promising compounds have already come from unexpected species. That means the unknown plants matter, perhaps immensely. A vanished flower, shrub, or tree might have held a future treatment for infection, pain, cancer, or inflammation, and no one would ever know what was missed. Conservation therefore becomes more than an ethical duty to nature. It becomes an act of medical humility. We preserve habitats not only because life is valuable, but because ignorance is vast, and disappearance can outrun discovery. A disappearing meadow can take future medicines with it. People often imagine lost medicines vanishing only in remote rainforests, yet a meadow can be just as consequential. Grasslands, hedgerows, wetlands, and edges of farmland hold dense communities of plants, many of them overlooked because they are common, local, or not visually dramatic. But common plants have shaped medicine before, and they can again. When a meadow is ploughed, paved, sprayed, or fragmented beyond repair, an entire network of chemical possibility can disappear with it. What fascinates me is how ordinary the loss can look. A field becomes a development site. A verge is cleared. A patch of rough ground is tidied away. Nothing seems mythic or tragic in the moment. Yet each loss narrows the living inventory from which future remedies may come. A landscape does not have to be exotic to matter. Sometimes the next medicinal clue is not hidden in a jungle. It is flowering beside a footpath, and then suddenly it is gone. The next breakthrough drug may still be growing quietly in plain sight. That possibility gives the entire world of plants a strange and thrilling tension. Somewhere, perhaps in a weed by a roadside, a shrub in scrubland, or a tree no one has tested properly, there may be a compound that will one day change medicine. It could help with pain, resistant infection, immune disease, cancer, or something we have not yet learned how to treat well. History gives us every reason to take this seriously. Many of the most important plant-derived medicines once belonged to species that looked ordinary, decorative, or easy to ignore. What fascinates me is how often greatness hides in familiarity. Human beings are excellent at overlooking what is common. A remedy does not need a dramatic appearance to have dramatic chemistry. It only needs the right molecule, in the right tissue, waiting for the right question. The next major discovery may already exist in sunlight and soil, unnoticed except by the plant itself. Plant remedies reveal that healing has always been rooted in the living world. For all our laboratories, hospitals, and modern precision, the deeper story reaches back into relationships much older than civilization. Human beings learn to heal by living among plants, watching them, tasting them, fearing them, and slowly discovering which could ease pain, lower fever, numb nerves, calm spasms, or change the course of disease. Even now, many medicines still trace part of their ancestry to that green world. What fascinates me most is the continuity. We are not separate from the living systems we study. We are one species reading the chemistry of others and turning it towards survival. The leaf, the root, the bark, the flower, and the resin all remind us that medicine did not appear from nowhere. It grew out of contact with life itself. That is why the subject feels so large. In every remedy, there is a conversation between human need and botanical invention, and that conversation is still going on. As we come to the end of our journey through plant remedies, it's remarkable to think about how much was hidden in plain sight all along. We've wandered through forests, fields, mountains, and gardens. We've met trees whose bark changed the course of medicine, flowers that helped doctors fight cancer, roots that soothed the body, and leaves that carried chemistry powerful enough to protect, heal, or transform. The more closely we look, the more extraordinary this world becomes. A bitter stem, a cooling gel, a fragrant herb, a thorny weed by the roadside, each one holding its own story. Some offered relief from pain. Some steadied the heart. Some changed how we treat infection, inflammation, or disease itself. And beneath all of it was a deeper truth. Plants were never still or simple. They were always busy, always inventing, always shaping molecules in silence, under sunlight, rain, wind, and pressure. So now, as these thoughts begin to drift and settle, you can let that green world grow soft around you. Imagine moonlight on leaves. Imagine the slow outline of branches against the night sky. Imagine roots resting deep in the earth, holding their ancient chemistry in darkness, while the air above them grows cooler and still. If you enjoyed this sleepy journey, you might like to subscribe, leave a thought below, or return for another wander through science with me soon. And if you happen to still be awake in a moment, there'll be another video waiting for you on the screen, ready to carry you somewhere new. But for now, let your breathing slow. Let your body sink deeper into rest. And let the day fall away, as if you too were settling into the calm rhythm of the living world. Sleep well, and good night.